So now in this video we're going to look at the photodiode. So the photodiode we're looking at now is the LED looking photodiode. It's not the little solar panel looking photodiode. But in any case, we have the photodiode there. You put it reverse bias, which means the cathode is more positive, the anode more negative. So that means it doesn't conduct when it's reverse bias, except for if light falls on the photodiode, it will conduct a certain amount of current right there. So there's always exceptions to rules. Some diodes are made to conduct reverse bias, and the photodiode conducts a certain amount of current while reverse bias. So that's important to understand. There's light dependent resistors that behave similar to the photodiode, except for they have a resistance that is variable depending on how much light is falling on them. And so as you increase the voltage across them, more current will flow. Whereas the photodiode is a little differently. For each photon that hits it, there's a certain amount of current that it will let flow through. So it's basically a current source. It sets a current. Now, if you get it bright enough, it's going to let a lot of current flow through. So in this case, I have a 510 ohm resistor right there. When we have 5 volts there, that means it's going to make it where we can't get more than about 10 milliamps of current, no matter what, no matter how well the photodiode is conducting right there. And if we get up to 9 volts, let's just say 10 to make the math easy, that means we'll get almost 20 milliamps of current maximum right there. So we're setting a limit with the 510 ohm resistor based on the supply voltage, but as long as we stay below whatever the maximum, the 510 would let flow through, at that point the photodiode is going to set the current. So now, what we're most interested in is current. There's a lot of things we can do with that current, but for now we're interested in the current. So we're going to stay in the milliamp range right there. We have a resistor to make sure we don't pass too much current, and also my power supply is set to limit current to 20 milliamps right there maximum. And so I opened up the circuit. Power supply is not really showing anything, but as we'll see, we're probably really close to about 1 milliamp of current with my lamp here at its brightest setting. So I can go anywhere to the negative supply. I got this alligator clip right there. I crimped the other end of a male-to-male jumper. I'm going to do the same with this one. So a couple benefits here is if I push on the components, that changes how well they are connected, and thus will affect connectivity. So I got to complete the circuit through the meter. That spot's bad right there. I damaged that. But yeah, I said somewhere around about 1 milliamp of current. It's actually closer to 2 because it says 1 milliamp on the supply. But if the power supply thinks there's just a little bit less than 2 milliamps of current, it says 1. It doesn't round to the closest number. So, any case, and it's not as accurate as a multimeter. Anyways, there you can see we got about 1.73 milliamps of current with the lamp at this setting right there. So, before I change the lamp setting, the most important thing to realize is this current does not depend on supply voltage. And I have not tested this out since the last time I made a video like this. But there you can see. So we got 9, we can even go to 10 volts. So it does change just a speck right there. But we doubled the voltage with resistors alone, in this case the photodiodes is what's setting the current. Resistors alone, you double the voltage, you get double the current. With the photodiode, you don't. As you can see right there, we can go back to 5 volts right there. So we got a certain amount of current, changes the spec, I think, as the component warms up, because it's fighting more voltage to set the current. It does change a little bit. One thing to be aware of with photodiodes is they tend to conduct better as they warm up. But there you can see I get it darker and it goes down. Just with the shadow there, I can cut, looks like all the current completely right there. Now I'm going to set the lamp to the dimmest setting right there. Again, 0.34 volts. It'll probably do better right now. But again, we're going to bump this up to, I could even go up to 15 volts. But yeah, we got 10 at this low current. We could go like 20 volts or whatever. There you can see. We got like 4 times the voltage, basically the same amount of current right there. And remember, as voltage goes up, things get hotter, but if you keep current basically the same, it doesn't, it gets 4 times as hot for the given current right there. So at very low currents, if you do 4 times the voltage, the component will get 4 times as hot as long as current stays the same. When it comes to resistors, if you increase the voltage, the resistor passes more current, and therefore you got voltage times current, and so it goes up a lot faster than how much you increase the voltage. Hopefully that makes sense. But in any case, there we go. We got about 0.34 at this light level, and to maximize how much current this will flow, so again we're at 5 volts, I'm going to put a flashlight up to it. So there you can see, as I said before, with 5 volts, 510 ohm resistor will get somewhere a little less than about 10 milliamps of current right there. And so that's what we expected. And let's go up to 10 volts. Again, make the math easy, even though I wrote 9 on there for some reason. We'll go up, and there we go. A little less than 20 milliamps of current, as I said before, because we do have that resistor setting the maximum current right there. So that's why I did that. I do have the power supply limited to 20 milliamps of current, so we wouldn't damage anything no matter what I did. But main thing is you can add some resistance in order to limit the absolute maximum current. So I think that's always a good idea, but a lot of schematics you don't see the resistor added. I don't know where this will max out, and not really too important because, you know, it's never a bad idea to add series resistance to set the absolute max that you want. Otherwise, as long as the resistor wants to conduct more than the photodiode does, the photodiode limits the current. Now, we're done measuring current. Let's get this plucked out. Again, I have a bad spot in the breadboard. That's why I move that down a little bit. So it's very important whenever you measure current, first off, get it where you're not measuring anything right there, and get the meter off of measuring current. If it has a voltage setting, set it to that before hitting the power button, because if you turn it on and try to measure something, it's always safe to measure the voltage, but the current, you could blow a fuse. This has an off setting, so we could have set it to off, but I'm going to leave it on voltage now. So we're going to come down right there, and the longer lead for the anode, because I haven't cut them, is a little bit longer than compared to the cathode lead than like most LEDs and stuff. So I'm going to kind of separate it a little bit to get it to fit in a little bit better. So that's long lead anode to the negative supply, short lead cathode to positive supply. Important you put it reverse bias. So now what we're going to do, again, I'm going to grab the alligator clips. So we can measure the voltage across the resistor because we have a resistor right there, and the current is going to be set across the resistor despite changes in voltages. So as long as we don't try to pass too much current, what we're going to see is it holds the voltage pretty steadily across the resistor. So we got about 0.212, lamp is at the dimmest setting, I thought so, volts across the resistor right there. So we have 10 volts at the supply right now. So this voltage should hold steady even if we go down to 5 volts. And there you can see. So again, we saw the current does change a spec through the photodiode as voltage changes a fair amount, you know. But for the most part, 0.2 volts is about what we had across the resistor when we had twice as high of a voltage before. Now, the resistor is not setting the current. The photodiode is. As current changes through the circuit right there, voltage across the resistor will change. So we got about 1 volt. So this light must be about 5 times as bright, I'm thinking, as before, because now we have 5 times the current going through the circuit. So if I double the voltage, there we go, across the resistor, still, it's about 1 volt. You know, again, a little bit of current flows as you put more voltage on the photodiode, just a little bit more, I think because it's warmer or something. But in any case, for the most part, it's holding steady. So in any case, yeah, we got the 10 volts at the supply, 1 volt across the resistor because the photodiode is setting it. And now at 10 volts, of course, you know, a flashlight, it's going to raise that voltage across the resistor right there. So this is where we do not want to exceed the wattage rating of the resistor. We can get about 5 volts across this resistor. There we go. That looked like that might have been a little more than we wanted to put across that resistor right there. So for that's probably why I set the limit to 9 volts. I made this a long time ago, right there. So I don't always remember exactly why I did stuff, but usually through a little testing right there, I figure out why. So it's important you do testing on there. So in any case, yeah, I'm gonna wrap it up again. When you're on voltage, pretty much safe to do anything, you know, as long as you don't exceed the voltage rating of the meter. Where you really can run into trouble is accidentally setting it to measure current when you have a voltage. And when I yanked the jumper out of there, it made the photodiode go flying. So in any case, I thought this would be like a 2-3 minute video. Went on much longer, but hopefully you enjoyed. So I'm going to end it there. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.